Now we start our discussion with another topic in power system, which is known as the short and medium lines. So basically, the transmission lines normally are characterized according to the distance. There are three types of lines, which are one is known as short lines, another is known as medium lines, and the third is known as the long transmission lines, which we'll be discussing afterwards. The short lines, normally these lines, the short lines are normally treated as up to 80 kilometers are treated as short lines. So the lines which are not more than 80 kilometers are characterized as the short lines. Coming to another type of line, which is known as the medium lines. The lines from 80 to 240 kilometers are normally characterized as or classified as medium lines. So 80 to 240 kilometers length of line, transmission lines, are classified as the medium lines. And one more line comes here, which is called as the long transmission lines. These long transmission lines are but obvious more than 240 kilometers. So any line which is more than 240 kilometers are treated as the long transmission lines. So short lines 80 to 240 are the medium lines, and the long transmission line has 240 kilometers of length. In the short lines, we have some assumption are there. So we know that there is a resistance, there is a inductance, there is a capacitance, there is a conductance. So in any line, the resistance and the inductance are considered as the series parameter of the lines, whereas in any line, the conductance and the capacitance are treated as the shunt elements. So the series element of any line would be the resistance and the inductance. These are treated as the series element or the series parameters. Whereas the capacitance and the conductance are treated as the shunt elements. This is important thing to understand. So please remember this thing as it is. The resistance and inductance are series elements. The capacitance and conductance are shunt elements. So in a short line, capacitance and conductance, which are the which are the shunt elements, are normally neglected. So the shunt capacitance and shunt conductance are neglected in the short lines. Shunt capacitance and shunt conductance. are neglected in the short lines, whereas these are present in the medium and long transmission lines. So this is the classification of short and medium and long transmission line according to their length. So we will be starting our discussion with the series type of lines. With the short type of lines. So remember this thing which we have discussed just now, that the shunt capacitance and shunt conductance are neglected in short lines. This is one thing important, and the length also. This type of question may be asked in the examination. So please remember this data. So we can represent the short line or any line by as a two-port network. So no need to discuss about the two-port network much more, but we can say that this is a black box, a transmission line. This is my two-port network, and the receiving end. So the voltage over here is called as the sending end. The voltage over here is called as the receiving end. The current which is entering, which is called the sending end current, and the receiving end current IR. These are the four things which are in a transmission line. So if we consider a transmission line with respect to the sending end, so we can write from this ES is equals to A into VR plus of B I R. Sending end in terms of receiving end, we can write like this. I can also write the sending end current as C into VR plus B into IR. Please remember this thing, that this in a two-port network, these things are minus, but here it is plus, because of the reason that in a two-port network normally my current is going in this way, but here in a transmission line the current is sending in current is coming from here, two-port network, then sending in current becomes the receiving current in the same direction, but it is opposite to the direction of a two-port network. So this is minus and this is also minus and this minus. So this minus minus becomes plus. So this will be plus. So I can write this same thing in as a matrix form also. Vs into Is is equals to A, B, C, D, which is VR and IR. In this way I can represent this as a in a matrix form also. So from this there are four different constants which I am getting, which is called the ABCD parameter of a transmission line, which we have already studied in network theory also. But for the sake of the understanding, we will discuss not going into the ABCD parameter, what are those, but we can directly now say that what is the value of ABCD parameter when we are considering a short line. So for short line, the ABCD parameter are like A, B, C, D. Parameter are like 1, Z, 1 and 0. Sorry, 1 Z, 0 and again 1. Says that AD minus BC is equals to 1. AD minus BC is equals to 1, we know that. So here A is equals to 1, B is equals to Z, C is equals to 0 and D is equals to 1. So A is equals to D is equals to 1, B is equals to Z and C is equals to 0 for short line. So from this, if I remove this thing right now, I can have one thing, that Vs, from this I can get Vs, V sending is equals to A is 1, Vr plus B is Z, Z into the receiving end current IR. And IS, since C is equals to 0, from this equation again, I can have a different relationship, that is 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 equals to C is 0, so 0 plus of D is 1 IR. So I can directly say that IS is equals to IR. These two relationships are very much important for the short lines. So from this we can deduce that I can find the sending end voltage if the receiving end voltage is known and the receiving end current is known, and Z, the impedance, is already given in the question. So I can find Vs from this equation. And since it's a very short line, so we say that the sending end current is almost equivalent to the receiving end current, and theoretically it's equal. IS is equals to IR. So these two are the very important formula for short lines. So please remember this formula. We are going to do some question on this formula. Vs is equals to Vr plus Z into IR, and IS is equals to IR. These two things are supposed to be remembered by each and everybody.